So if you're watching this, you want some help with adding mixed numbers, or you just feel more comfortable going along with the videos, but don't forget, you can always come see me, work with the coach, work with the peer. But let's do it. For this lesson in 7-8, I want you doing all the guided practice and then just pick one from each row for your independent practice before you can move on to the collab portion. All right, number one, how is adding mixed numbers like adding fractions and whole numbers? So adding mixed numbers is just like adding fraction and whole numbers because the steps stay the same. But you need to, actually, not even but, the steps say the name. And you need to consider place value. So when we're doing like things in the hundreds place added to each other, you have to line up the ones, line up the tens, line up the hundreds. So here you line up whole numbers and fractions. And you add the whole numbers to the whole numbers and the fractions to the fractions, and then you convert at the end. All right, number two, look at the example on page 298, which was the cactus example. Why is the denominator 6 used in the equivalent fractions? So we had 2 and 2/3. We had 1 and 1/2. These denominators were 3 and 2. And why did we use 6? Well, if I skip count by threes, 3, 6, 9, 12, 15. Skip that by 2s, 2, 4, 6, 8, 10. 6 is the first common multiple. It's also the lowest common multiple, and some people will say even the least common denominator. So that's why 6 is used. Ta-da. All right. Over here, some of these boxes throw you guys off, but the boxes are literally just there to help baby step you into getting the right answer. So 1 to 7/8 is equal to 1 and how many 8s? 7. If the denominator doesn't change, neither does the numerator. But on 1/4, we have to multiply by 2 to get 8, which means we have to multiply the top over 8. I refer to this as the giant 1 because 1 multiplied by anything is itself. So 1/2 is equal to 2/8. Because 4 times 2 is 8, 1 times 2 is 2. And now I can add. So I have a 1 and a 1, which is a 2. And I have a 7 and a 2, which is a 9. You should recognize that this is improper. 8 can go into 9 one time with 1 left over. So I'm going to take out 1 whole. I'm going to take out 8 eighths. And I'm going to end up with 3 with 1 left over. So 1 out of 8 is my answer. All right, now we have 2 and 2/5 plus 5 and 5/6. Fifths and sixths are not the same, but they are one away from each other. And usually, every time when that happens, you have to multiply them together to get your first common multiple. So 5 times 6 is 30. 30s are common multiple. When I go from fifths to 30ths, I have to multiply by 6. So if I multiply by 6 on the bottom, you zoom in here. If I multiply by 6 on the bottom, I have to multiply by 6 on the top. 5 times 2 is 30. 2 times 6 is 12. So my new numerator is 12. 2 and 2/5 is equal to 2 and 12/30. On the bottom, I went from 6 to 30th by multiplying by 5. So I have to multiply by 5 on the top because I'm multiplying by 1. 6 times 5 is 30. 5 times 5 is 25. And now I can add. 5 and 2 is 7. 25 and 12 is 37, which is obviously an improper fraction. So now I'm going to have to convert. I have to take 30/30ths out, which is going to equal 1 whole. So instead of 7, I now have 8. But after I take out 30/30ths, there are 7 left over. So this is 8 and 7/30ths. Ta-da! All right, if you're still with me, we got 2 more. When we're writing or when we're solving fractions, do yourself a favor and write them up and down just like you would if you were adding or subtracting whole numbers. Okay, so we have ninths and thirds. I want to change one of them if I can. If one can go into the other, do it. So 3 can turn into 9 by multiplying by 3. So I'm going to keep 4 and 1/9. But I'm going to change this one to 1 and something over 9. Now I have to figure out, how did I go from 3 to 9? I multiplied by 3. So what I do to the bottom, I have to do to the top. 1 times 3 is 3. I add, and I'm running out of room here. I get 5 and 4/9. Now on this example, 6 and 5/12 plus 4 and 5/8. Unfortunately, I cannot turn the 8 into a 12. Okay, so I'm going to have to skip count on this one to figure out. I know that 12 times 2 is 24. It's the second multiple of 12. And right away, I was like, oh, 24. 8 can turn into a 24. So I do that. So I say, okay, my new numerator is 24ths. So I got 6 and something out of 24. I got 4 and something out of 24. And now we just have to use the magic one to write our equivalent fractions. 12 times 2 is 24. So 5 times 2 is 10. 8 times 3 is 24. So 5 times 3 is 15. And now I can add these together. Again, I'm running out of room. But 6 and 4 is 10. 10 and 15 is 25 out of 24, which is improper. 24 24ths come out, and I have 11. And then I have one little 24th left. So this is 11 and 1 24th. Phew. Okay, that was a little bit longer. These do take time, but it's important that you understand the skill. So if you can show me that you understand the skill in 3 quick problems, then you're good. You don't have to do any more practice for now. But pick one from each row to finish. If you go and check them and you're wrong, do another one. Okay, the whole goal here is not just to do 3, but to get 3 right on your own. Okay, and when you're solving, remember, fractions must have a common or, like another word for it, denominator before they can be added, and you will be successful. One thing they also ask you to do, I know we've been practicing this a lot, but it's to estimate first and then find the sum. So that's something that you can definitely do in your head. Like, for example, this is 2, about 2 plus about 1. My answer is going to be about 3. Boom. This is about 2.5 plus about 6. So my answer is going to be about 8.5. Boom. All right. Definitely went a little long, but still shorter than when if we were going to do this in class together. Can't beat that. All right. Good luck self-pacing. You got this.